So right now the hard stuff, the stuff that people actually struggle with day to day. We decided to come up with a theme for this. There are a few blips on the radar that relate to this notion of document storage. Not to say that document storage is the only newfangled form of storage out there in the market. Everybody's heard of relational. There's also column family storage, key value storage, there's graph databases. There is a lot of traction with document storage, and I think within Thoughtworks this is the model, the alternative model from comparing to relational that we've had the most adoption with. So we know the most about this. So a few of the blips that Ryan and I are going to talk about. Hang on, how do I do this again? That's cool. Database migrations for NoSQL, aggregates as documents, MongoDB, Postgres. So I'm going to start by aggregates. Aggregates is very much, it's not a tool, it's not a framework, it's more of a conceptual idea that came out of domain-driven design. How many of you have read this book? It's a fair number.
Wow. You're all still standing?
Yeah, still standing. I mean, it's funny, right? Because we were talking the other night, Eric Evans is both brilliant and very hard to read and listen to. I think he's absolutely brilliant, which is why I pay attention to him. And the idea of aggregates is that an aggregate root, as Eric Evans defined it, more or less defined a transaction boundary around a subsystem or a subcomponent. And it also defined the boundary through which you must access any individual entity, component of this subsystem. So, for example, if we take an order, which is a pretty common thing in the e-commerce world, you're going to have this notion of an order, and you want the outside world, you want anybody who is not within this boundary here to access the order as one entity, and then to sort of drill down within it to get to the line items. If you want to save anything within that order, you want that to be one transaction. The traditional way of dealing with this in the SQL world is to shred this into multiple tables. So you're going to have, it's really cool, this order-lines table, for example, that has a foreign key up to the orders table. One of the things that our colleagues actually, Martin Fowler, Pramod Satterlitz, wrote a book on NoSQL, and when they were thinking about this, they said one of the really interesting paradigm shifts with NoSQL databases in general, except for graph databases, but certainly for document, certainly for key value, and certainly for column family, is that you actually model the data as aggregates in these databases. You take this domain-driven design of an aggregate root, and you can model that very directly. There's no object relational impedance mismatch that you get in SQL, where you have to take this relational model and then map it to how you reason about it in your object-oriented language, which is as an order that contains line items rather than as a table of line items that has a foreign key to orders. The tie-in to documents here is that you can do that as one single logical entity. So most of the document databases have Json as the language, the lingua franca. And you can imagine that you just have a single JSON document that represents this order that has nested objects for the line items that has an array within it, because JSON allows you to do that for the components and the payment details. So you can avoid a lot of this mapping logic that you have to do in traditional SQL. This is one of the purported advantages that we've seen in NoSQL databases, in particular object, where you have a strong object model and you want to model that directly without some of the mapping. One of our ex-colleagues, Ted Neward, had this famous article on object relational mapping. He called it the Vietnam of computer science because it's a really hard problem that you actually don't really want to solve. You just kind of were led to solve it with traditional database technology. So this concept naturally leads to some of the document databases because they do this really well. I'll let Ryan talk about Mongo, and then I'll tell you about better options.
So I resemble the guy that Pete was talking about. I'm actually just posing because I'm not actually a hipster. Nor am I yes, I try to do that. None of my pictures. This shirt is not hipster. So MongoDB, you can see that we have MongoDB in the adopt column. So I would ask, how many of you out there are running MongoDB in production? Wow, good luck to that. How many of you guys wish you weren't running MongoDB in production? That's pretty good. All right, so I quite like MongoDB. I've been using it for years. I was trying to do some NoSQL stuff before it had a name. And I think MongoDB is a really exciting technology. But I didn't want to come off as a fanboy, so I'm trying to pretend like I actually don't think there are bad things about it. So MongoDB, I'm coining it today. By the way, is anyone from Tengen here tonight? Oh, damn it, I can't speak for you. All right, so to be clear, we don't endorse technology specifically. This one's maybe the biggest risk because it's not an open source framework, right? We're just here to talk about what we think about Mongo and what we've seen in our projects. So I think, this is a quote from Tengen, they didn't pay me to put this here. The NoSQL database movement came about to address the shortcomings of relational databases and the demands of modern software development. I don't know exactly what modern software development, but I think it's what Pete was talking about. I have no idea how Mongo enters into that. Mongo's an amazing general purpose NoSQL database, right? If we think NoSQL, probably 4 or 5 different sort of areas of NoSQL that have nothing to do with each other, column families, graphs, key values, document stores, there may be a few others floating around. Mongo is probably the closest thing to an RDBMS that we have out there, but solving some better problems, and specifically the problem of document-oriented storage or aggregate-oriented storage, right? So what I want to talk a little bit about, what do I think it's good at? What do I think it's maybe not so good at? And hopefully we open up a dialogue. It's a very big subject compared to probably some of the other things we've talked about, so I can't hope to do this any real justice, but hopefully we can get a little bit of, given that not everybody's using Mongo, hopefully we can get a little bit of an overview. So Mongo makes aggregates, documents and that other terminology, made easy. Right? So you save documents into Mongo as one unit, if that's my order and all of my line items and my customer information, possibly. I can save that in one shot, I can load that in one shot. Right? It also happens to leverage BSON, which is binary JSON, so it's JSON for all intents and purposes for most use cases. And that's really interesting because obviously it's a very compact and easy to read format. You can do really exciting things with Mongo, like rip stuff out of the database and ship it over the wire directly and have it consumed by your JavaScript. I wouldn't actually recommend doing that in most cases, but it makes for a really great demo. It really helps with things like sparse or varying data structures. So here's, I think, really the nut where Mongo is very, 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 very important. When we have things like, I used EXIF data, for those of you familiar with photography, you can put lots of different things in a photos data stream. Most of it's non-standard, excuse my bad English. And you really can't control, so to speak, what cameras are going to do what. So if you're building an application for that, you might get one document that has sort of camera and ISO, pretty standard things that hopefully you're going to capture. But this one happened to capture the aperture and the color space. This other photo here, this other camera maybe is capturing lat long information and timestamp. Those two documents in a relational schema, they don't match up. So how do we deal with that? Do we have an ultra-wide table to deal with all possible things? No. Do we force fit them into columns in ways that are unholy? Hopefully not. Do we create lots of different tables for subs? There's lots of ways to try to make that work in an RDBMS. But for Mongo, those two documents go into the same collection without thinking. And I think the thing that's really interesting about this is it ends up giving you, no, that's too soon, hold on. The thing that's really, I've lost a bullet point. Where did they go? Mongo has great indexing facilities. So unlike a lot of the other sort of NoSQL solutions that are really purpose-built for very specific problems, again, Mongo is very generalist. And indexing is one of the early things that they put in. So indexing is very easy. I can declare an index in Mongo. When my app starts up, driver can wake up and let Mongo know that it wants an index. That can be very helpful. Production on large data sets, I wouldn't do that, but it can be very, very helpful early on in development. And so what you get with that is I can sort of declare an index in Mongo that says, I want to index one of those fields like timestamp, which isn't present everywhere. But Mongo's happy to index it when it is present, for example. And that gets you some really easy performance characteristic gains over databases that are more schematic, right? So I think that's really interesting. Another thing that's very interesting about it is super fast and easy high availability cluster setup. So with Mongo, we could very quickly and easily, and I would love to do the demo if we had time, sort of set up a 3-node high availability replica set on my laptop in about 5 minutes from there's 3 command line commands, boot 3 Mongos, go. That is very, very powerful when you're in early stages of experimentation. If you're working with your CI environment and you want to be able to sort of bootstrap Mongos in a very lightweight way. We're not talking Oracle here, not even MySQL. I'm an old MySQL fan, but so this stuff's really exciting. More advanced features that Mongo offers. It comes from a web scale world, but if those of you who follow what's out there, there's a lot of fanboy and this sort of detractor fighting going on about this stuff. Is Mongo really web scale? iteration manager from a project I'm on. Can't be that important, right? I'm actually not kidding, it really is. Hopefully he's not looking through the window. So Mongo comes from a potentially a web scale reality. So DoubleClick, I don't know if you guys know the history, it's not super important, but it was built for very large data sets that had very heterogeneous data structures. And so that's where it comes from. People argue, is it web scale, is it not web scale? I definitely don't want to have that argument tonight. It is, in any case, offering some features in that space, which are very easy to use. And so I continue to point out, I think Mongo has really made a lot of hard things easy. There's some seductiveness in that can get you in trouble. But so sharding, including auto shard rebalancing, very easy to set up. Sharding is always very, very hard, so I don't want to make you think that Mongo solves that problem, because there's no such thing as solving the problem of sharding and making it easy. But they do make it very easy to set up. Operational monitoring, again, out of the box, this is a tool that, let's be honest, it's not as old as Oracle, right? It doesn't have every feature in the world, but I think they've done a great job in slicing through the common things you need, like the ability to monitor the database easily. They have a REST interface, out of the box, set up Mongo, and you can sort of ping the REST interface, cluster information, connection information, all kinds of good data available via REST, so now you can couple it to your other favorite tools like curl or wget or whatever. So that kind of stuff makes Mongo very easy to operate, again, at the beginning. Now if you've got and terabytes of data, of course you're going to run into challenges, and Mongo hasn't solved all those things for you, right? But it definitely gets you off the ground fast. So one thing I did want to point out quickly to a new feature in Mongo, the aggregation framework. Just a quick thing, a lot of people talk about Bongo Mapreduce. Again, the detractors will say, oh, it sucks, it doesn't work well. Again, it's not trying to be Hadoop. What Mongo did realize, though, I think, was that the common operations that require aggregates, right? I want to do sums, queries, projections, that kind of stuff. The Mapreduce model wasn't really the best model. Mapreduce in Mongo is actually quite good if you want to transform a collection into another collection and sort of do projections or other filtering in the process. But it's not good for ad hoc work, to be honest. It was single-threaded, it still has lots of challenges. Instead, they introduced the aggregation framework in 2.2. We're now in version 2.4. And what that can do with single queries is pretty interesting stuff. Like, this is just a quick document. It's a blog post thing, got an author, got some tags. What this does here, it says, let's say I want to roll up, right, I want to roll up by tags. Who are the authors that wrote about these tags? So, you know, Bob wrote about fun, and he also wrote about good, and Toby probably wrote about fun because he's a pretty fun guy. If I want to do that query, sorry, I couldn't resist. If you want to do that query, that's a single query in Mongo where I can project, which basically unpacks my documents and sort of breaks out that array, which is an embedded array. We're not talking a lot about data modeling, but this is pretty cool. You can embed arrays inside documents. This unpacks that, it unwinds the tags, and then it regroups on tags, and it adds to the set the author value. Right? So then I come out with a data structure that's basically, by tag name, here's the authors that have written about that tag. That's pretty cool. And I think that's easier than SQL, actually. You know, I don't have a lot of temp tables in the meantime there. It's not that SQL doesn't do that, it's just that I think that does it really nicely. And the other thing about the aggregation framework, I have a bad habit of changing too soon. The other great thing about the aggregation framework, it uses the pipeline concepts. We talked a little bit earlier about Unix tools and how you compose stuff. That's the model the aggregation framework uses. So I can take operations like group by and add filters and other things and sort of, in fact, what we saw in this query here, this is really a pipeline. It's first I want to project and do some unwinding, and then I want to do some grouping. I can do arbitrary amounts of things in a row to get from the transition from the initial selected documents into the projected final result. I think, so worth checking out. I don't think we can talk about it in any more detail, but worth checking out how that works. Another thing, I think that you get some really, you get some other really good stuff that's kind of between the lines. Very easy to install and manage. We talked about that. Agile development, is anybody here sort of in a big enterprise? Yeah? Okay, we got a couple of people, cool. So in the enterprise, I had a personal experience on a project where Mongo, yeah, I'm sorry, but we all have to do that. Had a really good experience with Mongo, not because Mongo was a web scale, this, that, or the other thing, aggregate thing, but bringing it to an enterprise where the DBA sort of group was really becoming a bottleneck to development. They had a lot of practices and policies, and they had an SLA of 4 days to be able to add an index to your tables. And what are we talking about? This is crazy in modern world, right? But it's still happening. So sometimes technological change, assuming the technology fits your problem space. Now, I obviously wouldn't have brought Mongo if I didn't think it fit the problem space, but we also brought it as a way to say, hey, this is kind of like a developer level tool. It's not a database, right? We're going to keep it close to the app. And in that way, it kind of skirted around some organizational dysfunction and actually allowed us to move really fast. So if you think about it, Mongo allows me to set it up really fast. It allows me to, if I don't have a database and I start to use a database in my queries, Mongo just creates the database for me. right? So all of these little subtleties turn out to be wonderful for fast development, fast prototyping, experimentation, being agile, additive development where my documents are increasing, etc. Also, so I think it also really promotes, I'm going to call it a new sort of app-centric development paradigm. Kind of sounds new agey. I don't have crystals in my office. What I think this means is when we look at the people who are doing some of the really complex, tricky web-scale stuff, what we're realizing is that the database isn't special, right? It's really tightly integrated to the app. Like, the way the app thinks about the data is critically important. It's no longer that the database is over on the side. And what's interesting is there's, even Monty over at MySQL, I don't know if you guys know Monty Weediness, but he actually said some years ago that today's apps are so complex that really the database is just like a slave to the business logic of the app, right? That we can no longer look at things like transactions or constraint management in databases as the sole tool for managing those domains, that actually apps need to own that. So apps need to understand what's valid for their data and what are the usage patterns that should be, and the database is really just persistence. And if Monty at MySQL is saying that, you can be sure that a tool like Mongo really helps us move in that direction, right? It doesn't offer all the constraints. It's schema-less. We'll talk a little bit more later about that, right? It forces the app developers to start thinking more about long-running transactions are a bad idea. Mongo doesn't give you very complex transaction semantics. It gives you basic semantics. Some people think it doesn't. It has sort of durability in transactions around single documents. And that's a good thing, because they're already aggregates. So we no longer have to have transactions to manage, as Brandon talked about, our, what was the word you used, our sharding, splitting, slicing.
It was really intelligent.
Whatever he said, awesome. You don't have to do it, right? And so transactions, if you're using Hibernate or something, I know it's hiding that for you, but the truth is you're still wasting a lot of performance in managing those things in certain cases, right? So Mongo pushes us, I think, in a direction as developers to say, you own that problem. You own the data modeling problem, you own constraints management, and everything that the app does should be uniformly tested and visible in the intentional code you're writing in the app. It should no longer be split between the two tiers. So I think that's a very, very valuable concept, to Pete's point again about intentional code. I want to go to my app repository or gateway layer, whatever you like to call it, and I want to see everything that matters about my data there. I don't want to see it half in the database, because when it's half in the database and half in the app, actually a quarter of it is nowhere, right? And so except your users figure that out later. So Mongo has a lot of nice little easy performance levers. Oh, I got a question back here. Yes.
So there's a whole lot of things that quote I own, but certain of those things have consequence at scale.
Yep.
I mean, I introduce an index, that's fine, except that the index is the person ID number of the citizens of China.
Yeah, I think I've read that.
So TBAs have a reason.
Yep.
I don't love them any more than you do, don't get me wrong.
But don't get me wrong, I don't dislike them as a race or anything. or whatever.
But no, it's just that
yes.
some of these things at scale require different levels of expertise than what an application developer is going to be converting.
So I think that's a great point to hotly debate. So we can have a cage match after on that one. But I take what you're saying very seriously, and I think one of my answers to that question is, if you're doing, and not everybody is, but if you're doing proper continuous delivery, let's even call it continuous integration at some level, right? Then you should be looking for those really representative data set problems, and you should be testing those in an automated fashion in your pipeline. I would prefer to see that world. Granted, that's not happening everywhere, but that would be the first answer I would wish for, is that all those concerns are captured by the development team as a whole. I don't claim every app developer has to be the expert, but I do think that the interrelationship between the application usage patterns and the data is something that both parties need to be at the table for. And I think it's the breaking down of the silo. In fact, I agree. Like the very thing I was promoting, I hope is a pendulum swing that swings backward. I would much rather see us working together and bringing our expertise to the table, but I think we have to break through some process garbage. Because I also have 95% of my examples in an enterprise that I work at are not, they're not that kind, right? The data sets are not so huge that they can't be managed. It's actually just bureaucracy. But I totally respect that, and I think that's an important concern. In fact, Mongo, as I said, is not good for everything, and we have to be careful. The last thing I'll mention that's between the lines, Tengen I think has excellent support. For a small company that's behind, small relatively speaking, behind an open source tool, excellent support. If you're 4 kids in a garage, I don't know if they give you good support, but I can tell you that their enterprise packages and on their mailing list, a lot of their engineers are super responsive. And that's important because Mongo's not perfect. right? I have a case right now where I have a sort of an slightly older version, a 2.0 series version of Mongo that's still in production. It's blowing up with a seg fault, trying to run Mapreduce. A, don't run Mapreduce. B, don't run an old version of Mongo. But if you're doing that, right, I can still get somebody to help me out. They have a new JavaScript engine, actually, 2.3, I think. So, there's lots of reasons. The point is, the guys are really good. So if you're using open source technology, I think this stuff is great. The not so good, so you're not going to do ad hoc business intelligence on Mongo today, in my view, right? Especially if you're using tools. If you're bringing in kind of MicroStrategy, Cognos, whatever, they really like relational databases and they like relational models, and they're going to kind of barf on this. They can talk to web services and you can use the REST interface of Mongo, but it's not natural. And the aggregation capabilities that we talked about are quite good on reasonable sized data sets, but I wouldn't really want to do sort of BI, heavy BI stuff with Mongo at this stage. I would, however, not hesitate to recommend more of a polyglot model where Mongo is a transactional store if it works for you, and then you fork it over to a traditional RDBMS for doing reporting. That's very viable. But polyglot is shiny, however, it is not simple. You are actually adding operational complexity, so I don't want to pretend that that's not an issue as well. Complex transactions. So back to that dev model I was talking about. Complex transactions is a classic credit-debit problem that everyone likes to use. I think that's a funny joke because financial institutions have reconciliation processes. They don't think the transactions work properly. But every example thinks they do. And so Mongo clearly has single document transactions. Like save one document, that is fully guaranteed, especially if you're using a journal and you have durability enabled, that's basically as acid as you need. But you can't save two documents transaction. The good thing about that could be that we get developers to stop thinking about transactions that span 50,000 things, because that's not a good idea, right? So how many business cases really can't afford to have a reasonable sequencing of events that's eventually consistent? I've not found that many. But truthfully, again, I think to your point, right, most people aren't still thinking that way, so that can be a bit of a problem. You can implement your own sort of optimistic and pessimistic locking approaches inside Mongo, but you're going to roll it yourself, and that's not trivial necessarily. Problems which actually benefit from normalization. So obviously, I think we all know that normalization came about because disks were expensive back in the day, like 30 years ago. And at my enterprise, actually last year, they were still paying, I don't know, like $5,000 for a terabyte of storage. I don't know why. The point is that Mongo is not optimized necessarily for that. Mongo stores in its key value storage all the keys with all the values. It needs to do that because of the potential sparseness or potential variability of the data. So it doesn't have a column or model yet. It may at some point, but that's not optimized, and so your storage can balloon if you're repetitively storing keys. Some people argue you should actually store keys that are kind of compressed by your app. Yes?
So in the order that you use at the beginning of your example, what do you do when the customer address changes?
The name of the key?
You've got that in a billion different...
You suffer. That's one of the, there are strategies for that. So some people are doing mapping. If you have really large data sets and you're worried both about change and volume, this wasted key space that keeps getting repeated, then you might map them yourself into a code, in which case the app has to sort of demap that to be able to use it, but the database is pure from that point of view.
I don't think the key. Sorry, I don't think you're asking about the key. I think you're talking about the data, right? The data of the address change.
Well, the way it was shown is you show everything about the customer in the document that
right.
you send.
And within the context of order.
Rather than a customer ID, which
yep. Oh,
synthesized.
So schema design is a fascinating problem in document databases because sometimes we actually don't keep an aggregate quite the way we showed, but you actually do split some pieces out if they're really factorable. That leads to often two different reads happening, so it's not free. You don't have joins, right? So you have to balance those. But the simple answer is you migrate, which is something I want to talk a little bit about later. And that's a problem which would have benefited from normalization, right? So it's not for everybody, this stuff. Like, it is not trivial, and you will have to deal with those things, and you must be thinking at what's going to look like at scale. If I get to scale, what's it going to look like? That said, I always tell people, eBay, Amazon, nobody got it right the first time, so don't try too hard and take advantage of the development accelerator to get your product out to your customers. If they actually love it, it's a great problem to have. Most startups never get that far. So, the scaling features may give you a false sense of security. I've lived with a lot of the challenges of scaling anything, including Mongo. Things work out of the box really well. When they get, like for example, an HA replica set sounds magic, right? In 5 minutes, I can actually set up a 3-node replica set. Data is stored in 3 places. I have the quorum protocol happening for me. I knock nodes down. Everything works. Looks beautiful. What happens when I've got 10 terabytes of data and I get a corruption of my primary? Well, Mongo doesn't have a simple answer to that. You have some serious DBA foo to get in there and get that fixed. How are you going to deal with that problem? How many times did you replicate your data? What is your failover strategy for serious problems? It's not trivial. So you just have to be careful to not get into the lulled sense that Mongo has solved all the hard problems. But it has addressed a lot of them, and that's pretty cool. You just need to keep thinking with it. And again, I think the 10gen guys do a lot of work to try to help people through those problems. But overall maturity is not obviously where Oracle is, or necessarily even MySQL in a lot of ways. I've got a seg fault on a basic MapReduce operation in a fairly recent version of Mongo. Ideally, that wouldn't happen. Is that because Mongo's not mature? We could debate that, but just keep your eyes open. It's still nascent technology, but it is an open source technology with a very strong company behind it that is actually targeting general purpose use cases. It is not targeting only big data, right? So I think that in that sense, Mongo is pretty interesting. The last thing I'll mention quickly, not that I do anything very quickly as you can see, is the 10gen offers a couple of cool things. The Mongo monitoring service is a SaaS-based solution where even if you're running Mongo on premises, if you're willing to open up some ports, that REST interface I talked about can be used to interrogate, and there's a whole monitoring dashboard that can actually watch your Mongo instances for you. Again, if you're at that point of scale where you'd rather not have to reinvent the monitoring infrastructure that you wish you had, this could be of assistance. If you're running AWS, this could be of assistance. Backup service, very similarly, using Mongo's replication sort of mode, they will actually put an agent near your box, replicate out to another agent where they can do snapshotting around with a number of strategies that that can be implemented by you as well. But if you don't feel you have an ops team that's ready to take that on, you might be able to get a backup service as a SaaS from them, even if you're running Mongo sort of on premises. So those are kind of interesting options.
So one comment I'd make about having Mongo in the adopt category is that it's very fashionable. I think there's a lot of people who are using it because it's web scale, it's the new thing.
Yep, couldn't agree more.
So it's sort of like, well, what are the, I mean, are there any kind of really good criteria for deciding, okay, here's my project, I should use MySQL for this, even though it's boring, and people like it, versus, versus a,
wait, I'm going to have a cage match with him first.
Yeah.
Okay. Fantastic. That might make it.
Yeah, so
we're friends, by the way. So
if not, you are now.
So so some kind of easily applied criteria that would actually offer true guidance to people.
Brandon seems to want to come on and to actually take that question, so I'm happy to let him do that.
Yeah,
or I'll
so
take it first.
I do, in the context of a story that I thought of this morning around the talk around Postgres. So maybe I can just, if you can wait 2 minutes, then sure. I'll give you a story. And I hope that by parable we can answer some of that, if not by a bullet list of.
If not, I haven't checked this technique. I actually kind of do. I mean, and Brandon's coming on, but the quick answer will be things like the aggregate storage. If that's really going to pay dividends for you in either your write patterns or your read patterns, that's one place to look. Also agile development, right? If you're going to be changing your schema a ton at the beginning as you find your way into whatever your product is going to be, those are really...
I'll give you an example of, say, agile development, right? Like, so if you're using an ORM like Hibernate,
exactly.
It just generates the schema for you,
absolutely.
And you don't have to worry about it, right?
That's right, yep.
So, what about the connectors for pulling data back out? Because one of the things I need to do, a particular problem I'm solving, I got to collect the data, but then I have to report it in a number of different ways. Which,
okay.
I mean, the SQL world has like a gob of solutions.
Right.
That. How about Mongo?
Yeah, so Mongo doesn't. And I think that's really where you get polyglot, and you end up pulling the data back. So you're using Mongo because, as I was saying, the actual transactional model you have from your app would benefit substantially from the aggregate model of Mongo versus Hibernate, which, again, if you're doing a lot of writes, for example, there's a lot of overhead in splitting all that data out comparatively. In the average app, a lot may be nothing. It may not matter. I mean, Hibernate is very efficient and very optimized at a lot of things it does. So I can't even say that on any given case, Hibernate's not going to perform reasonably well. But if you get to certain scale levels, Mongo's giving you the advantage. Then you've got to decide, do you want to project the data out of Mongo and into that reporting solution? Or would it have been better just to go with the MySQL to begin with? And the answer to that is, frankly, probably go with the MySQL to begin with if you know you have those requirements. As I said, if you're agile development, certain usage patterns of Mongo that are optimized are not front and center in your problem space, I wouldn't rush to use it. As much as I say it's doing a lot of great things, I wouldn't rush to use it.
if I could just interject very quickly at that point, I mean, even if you're using a completely relational solution, it's rare that you use the exact same data structures in your database that you use for your transactional operations, for your analytical operations and reporting operations. So if you either have a separate set of tables or a separate database in which you do an ETL in order to do your reporting functions, if you're operating at that kind of a volume anyway. And so to some extent, at very large volumes, this problem has a solution with a different form rather than just using, it's only at small and moderate sizes that your relational databases can function both as a transactional store and as an analytical store. At very large volumes, you end up having different solutions for those problems, even in the relational world. So maybe it's not that different with the NoSQL world. Admittedly, there are other subtleties hidden over here, but perhaps it's not as different as it appears at first blush.
Yeah, and really, you have to try to measure what are those gains going to be in practice, right? From a development point of view, if you're going to be really wanting to drop and recreate your schema constantly, Hibernate automates a lot of it. It still takes time. Mongo, it's totally free. So, is that actually, does it matter to you? Maybe it doesn't. But maybe it does. You have to look. Do you have a DBA group that gets you on a 2-day SLA to get those changes in schema in? If it does, it makes a huge difference, right? If you have total control of your database, maybe not. So all those things need to be added up.
Quick question. Do you have experience working with any other NoSQL databases besides Mongo?
Yes, but not in the document space. So the document space, Couch is the only other database I have used at all, and it's not nearly at the maturity level of Mongo, in my opinion.
It's a different problem.
If you mean the sort of distributed reconciliation problem, it also thought it was solving the document problem a long time ago. Today it's become marginalized. I would argue.
We've used Lotus Notes, which is a document database.
So I mean, the short answer is, yeah, the problem space is what I tried to allude to at the beginning. I think that NoSQL is a stupid term because, frankly, all those problem spaces are vastly different. Key value stores are high-speed caches, right? Graph databases solve a totally different set of use cases. Column family stores solve a totally different set of use cases and are a pain in the to operate. I've done it. It's painful. Like, don't ever open up Cassandra if you don't need it because it's painful in many ways. But it solves an incredibly hard problem, right? So in that sense, none of those areas to me even have vague overlap, truthfully. Now, within those spaces, there is some of them have more like React and Redis. You might argue about which one you want to use in a more of a key value world, etc. But I think Mongo for me is pretty much the leader in the document space, if that's the right fit for you.
Are you still addressing migrations in Mongo later?
Yep. Okay. Sorry.
Before I go into the next section, do any of you work at Oracle or Microsoft?
So you may leave now.
Because I have some legal issues with presenting the next. So a couple, maybe 3 years ago, I forget exactly how long ago, I went to a NoSQL trade show, and this was back in the time when NoSQL was only used by people who rode single-speed bicycles and sipped espressos and had their pant legs rolled up. And for obvious reasons, the traditional vendors have some reason to protect their space. There's an encroachment that the NoSQL renaissance has imposed upon the traditional vendors. And there was a salesperson from both Oracle and Microsoft at this conference, and they were quite aggressive in saying, well, we need to educate the audience. Both of our databases have document storage, we have XML storage. And in fact, the audience had to shut them down at one point. And I think, to some extent, what they're saying is fair. They actually do have some ability of document, to manage a document store within a relational schema. However, they're very clumsy to use. I used SQL Server's XML store maybe 8 years ago, and it was very painful. While it did the job for us, and 8 years ago was a long time ago in technology, it's not something that I would ever recommend anybody use again. So last year, I was working for a market science company, and they had a really interesting, fascinating problem. So they send out a bunch of surveys, and there's this notion of a panel, which is tracking how an individual user responds to various surveys over time. And each survey is custom built for a particular business. So you might have Nestle sending out surveys around chocolate consumption or something. You might have NASCAR sending out surveys around who's your favorite driver. So if you were to model this in SQL, you have some fairly challenging problems. And I actually have some pretty deep experience with what's known as the EAV pattern, or Entity Attribute Value pattern in SQL, which is a way of basically giving up everything that the relational model gives you to force fit schemaless data into SQL. And it's something that I would recommend to no one. So at this, however, another requirement at this project is that they had a really deep requirement to track activity. They needed to know how many surveys you answered, how many forms you replied to, sort of where you were in the process of an individual survey. And they wanted to do some pretty intense aggregate reporting, getting to your question on aggregate reporting. They wanted to do a lot of that on this project. And so I went there, and this was an interesting kind of greenfield problem. And so after thinking about it, I recommended a polyglot architecture. I said, okay, well, let's use Mongo for the schemaless stuff, the survey answers. Because it's schemaless, you're not going to be able to force fit this in a performant way into SQL. However, on the flip side, we're not going to be able to force fit this aggregate reporting that you have to do for tracking activities into Mongo in a performant way. And there's some people, and I think Ryan's one of them, who would argue that you actually can do that all in Mongo. And whatever, I could agree with them, but then we'd both be wrong. So I recommended this, and we went down this path for several months, and it was working okay. There were problems. There were problems that we walked into with open eyes. So you can see obvious problems with transactionality between saving a single record in both databases. And the DBAs, from the very beginning, were very resistant to this idea of a polyglot system with SQL and Mongo. And something like 6 months into the project, one of the DBAs came back and he said, have you looked at Postgres recently? And I said, no, that's stupid, because you can't force fit the schemaless stuff into a SQL database. And they said, yeah, well, check out this HStore and this JSON stuff. And I said, no, and it turns out that Postgres actually has matured. And I think of all the sort of traditional relational databases, Postgres has adapted by far the best to this NoSQL world. They've taken a lot of the lessons that NoSQL has learned, and in my opinion, have done the best job of the traditional vendors and bringing in the best of that world. Now, I have 3 projects where I've used Mongo. I've never used the NoSQL Postgres extensions in production, but I've looked at the website, so I'm pretty sure I'm an expert. They have a few different options. They have XML, which seemed like a good idea at the time, but the time was a long time ago. It's still there if you're particularly masochistic and you want to try it out, but it's not something I would necessarily recommend. HStore is this kind of interesting hierarchical data store that looks a lot like associative arrays if you're an old Perl hacker, or hashes in Ruby. It's kind of a hash table map type approach. And then JSON, which looks very similar to Mongo. And it's interesting, because had we stored our data all within Postgres, some of the problems that we did solve with the application layer, in terms of transactions and the sequencing of activities and reporting, perhaps could have been solved all within Postgres in a more elegant way. So HStore, this is an example of HStore. You see that the data type is HStore, and this is an extension. This isn't baked into Postgres. You have to install an extension. It gives you an associative array, and you can nest this. You can have multiple levels of this. Like this could be itself an HStore value if you wanted to. And then it gives you a bunch of pretty interesting operations around querying whether a key exists, whether values for that key exist, whether a set of values for a given key. Typical operations that you kind of expect out of associative array type operations. You can model documents as associative arrays. Perl did it for a long time before we came up with some of the document stores that we use today. The more interesting option that I think is JSON. And you can take exactly what you want to put into Mongo as this JSON document. So not exactly, because JSON is non-binary, and Mongo does give you some ability for storing binary data. But almost exactly what you want to store in Mongo, and you can put it into JSON, into Postgres. Now, I will admit that the syntax in Mongo I find a lot more elegant than the syntax that you're going to use in Postgres to query JSON data. And the documentation, because this is still relatively new, which is why we have this in the assessment. It's something that we're interested in, and I'm one of the loudmouths who promoted that we should be interested in this. But we don't necessarily have a lot of production experience using this. So it's still something that we're interested in, but we're not really sure where it fits yet.
Right. Does it support embedded arrays within documents?
Absolutely, yeah, it's JSON syntax.
So it has all of the push pop stuff.
It has all the push pop stuff, and it does give you some ability to query this, not necessarily as rich, I think, or as indexed as Mongo.
Yeah.
Although I'm not quite sure. I think it actually can. You can index some of the subarray stuff like you can in Mongo, and it actually can be quite efficient in that. And if there's, at least in some benchmarks, it's beat up Mongo. Although benchmarks are always questionable. The syntax, though, you can see right here. Like this is not necessarily something that you want to become an expert in figuring out how to write. But the fact that you can store schemaless data in a relational database and have one operational store for everything is perhaps quite useful. I think had I known about Postgres NoSQL extensions back when we had started my last project, I probably would have explored this a lot more and done a lot of spikes around it, because I think it's a really intriguing possibility. Any questions before?
So NoSQL migrations. Interestingly, Mongo was in the adopt ring. I could argue with that. Actually, as Badri mentioned, we say adopt when we think that something is really fit for its purpose. And in Mongo's case, I think it is fit for some purposes, but still there is that sense of we're promoting it. And I think that Mongo is still a fairly sharp knife. And we have to be careful because you can cut yourself. Interestingly, NoSQL migrations is in the trial ring. And I think if you are using NoSQL and you're not thinking about migrations, you should probably leave now and go check with your ops guys, because something's broken. Like this, I don't know how you're not doing this if you're actually running a NoSQL store. Just like with a relational store, how do you deal with migrations of schema as you move from sort of one version of your software to the other, right? And so we have lots of tools like liquid basic stuff. But we say, well, in the NoSQL world, we're schemaless, right? So like it doesn't matter. Schema's non-issue now. Forgot about it. And so a classic example, though, like, and I borrowed this from Martin, so this isn't my fancy drawing. If I'm going to go query the customers table looking for customers that have a zip code or whatever the heck that is, and I accidentally, or just I've changed my code at some point, start inserting keys called zip code instead of zip, obviously that query is not going to find that data, right? And that would be a pretty serious flaw in that particular case. So in reality, I have a very distinct implicit schema, as Martin and Pramod and Brandon mentioned earlier, they wrote a book. Implicit schema, your app has a very serious idea of what the schema of your data is, even if your database doesn't. Right? So the schemaless thing is very much a red herring in my opinion. And so given that, we need to think about migration. When my app moves on and starts using zip code as a key instead of zip, what am I going to do with all the existing data? So we have a couple of flavors of this that people are using. What I would call runtime migrations are migrations that you do typically at read and write time, and usually supported by background jobs. So if we go back, again, original NoSQL solutions, very, very specific purpose-built tools for very hard problems, large data sets. Most of these guys couldn't afford to run a static migration and have downtime. So they either had very, very large data sets or very, very high operational requirements that would require them to do fancy stuff. Like, when I'm reading the data, automatically transform it into the new schema so the rest of the code understands what it's getting. When I'm writing the data, perform migrations on the fly. And usually aided by a background job that takes 5 days to figure out how to translate the 7 terabytes of data, or the 70,000 terabytes of data, right? The large data sets will require this, even with an RDBMS. So this is not unique to NoSQL. I've been doing this in MySQL years ago when we had large data sets. We couldn't afford to upgrade the schemas. It was quite an arduous process to think through how I could either clone tables within schemas. There's all kinds of shenanigans you had to do. The big problem is this is really complex to code. Right? It requires very tight integration between the database, the understanding of the database and the application, and it requires some pretty good understanding of how asynchronous operations and the kind of order of operations problems that can occur. It's not for the faint of heart, let's say, and you can fall down in a lot of ways. But given that NoSQLs are moving more into the mainstream and are solving some valid problems on smaller data sets, it's become reasonable to think about deployment time migrations again. And so on the radar, to be honest, Badri, you can tell me, were you guys talking about runtime migrations or deployment time migrations?
Deployment time.
Specifically, right? The sort of classical migrations.
Yes.
So Thoughtworks sort of, I think, I'm going to say pioneered, because my knowledge is not good enough to say who else might have been doing it before us. We sort of wrote a tool called DB Deploy. Pramod Sutherlaj, one of our principal consultants and database expert, sort of did that a long, long time ago, maybe 8 years ago. And that kind of led, I think, the way for tools like Liquibase and other things that allow you to write scripts that capture sort of point-in-time changes between two aspects of your schema, and possibly data migration as well, and allow you to sort of version them such that your deployment process can only run incrementally the things that matter. Okay? So those are really key points, right? They're version controlled, they go with your code, so your code and essentially your database migration come together, and at deployment time, either your application automatically upgrades its database if it's kind of a smaller product and that's sort of the right user experience, or it's something that you run, and you would run it as in a CI-controlled process, as well as something that you're doing at runtime, sort of when you're actually deploying. So you'll be testing your migrations. Now, those things, for NoSQL, there is no schema in the database, so they tend to be data-only migrations. That doesn't change the point that they're still coupled to specific code changes. They can be incremental, and they should be able to be run in your CI or in your deployment process. I can't stress enough the importance of testing your data migration strategy in your CI environment with, I think to the earlier point that came up, representative data samples. So this can include volume tests to understand how long your migrations will run, whether they've been coded in a way that actually will make them successful on large volumes of data, easy to write trivial code that works on 5 rows that will blow up on any real amount of rows. So you need to make sure that you're not only testing it in CI, but that also you're testing with representative data sets. And if you're going to think about rolling your own, because, I mean, frankly, in the NoSQL space, there's a lot of things that we do still have to roll our own. Again, for Mongo, for example, we have some options. There's a Java-based option called Mongeese. There's a Ruby-based version. There's also Mongo Migrations, which is shell-based and kind of language agnostic. But if you're in some of the other NoSQLs, there aren't really good solutions. So if you're going to roll your own, some of the things that we've done on projects that I've worked on or that I've seen others do, make sure that your migrations consider sort of up and down. What's the sort of forward-moving migration, and what's the rollback path? When you're doing data-based migrations, that's not entirely trivial. Not that it is with schema migrations either, but a lot of people forget that again. I'm just migrating data, right? But a lot of operations are destructive. So, for example, in Mongo, a thing that I like to do is say, and this is, I'm not going to say a tool is going to support you, but make sure that before you migrate data, identify what you'll migrate, capture it into a temporary collection. I personally like naming the collection for the actual migration ID so that you can keep those for a period, perhaps until you rebaseline, and then you can drop your temporary data, and then move forward. That allows, if you need to roll back, if you have a series of migrations to perform or any other aspect of your deployment fails, you might be able to roll back your data. That is very, very important if you're on large data sets where backup and restore might not be reasonable options. Snapshots can be very good options for that, but again, sort of deeper topics. Sorry about just resetting that slide. I don't know how to use any of these things. I think I just went back like 400 lines. Note to self, careful with the buttons. Unit tests. Something that I think is kind of interesting too is, can you write some tests in your migration framework, which actually sort of, at migration time, make assertions about what you expected to occur? That can be really valuable when you get to that representative data set stuff. Maybe there's some things you didn't think about that weren't in your representative data set, and when you get live, that can be one of the things that triggers a rollback, because it says, what you thought was going to happen with this data migration isn't what just happened. And that can be anything from understanding that I no longer have any of the things that I expected to have, or counting how many I expect. There's lots of options. Similarly, sanity checks, you might want to think about sort of before and after. I actually have seen a migration delete 80% of the database. That's not if you're going to run 6 or 7, I think Toby was around when that happened. So if you're going to run sort of 6 or 7, some arbitrary number of incremental migrations, good idea at the end of the whole envelope to be able to ask yourself, is there anything that I could assert? I don't expect any of these things to make my database smaller. Number of documents, volumes, whatever.
It was 100% of the database.
Oh.
And we had unit tests, but they tested completely the wrong things.
Yeah. Sanity checks are just another axis where you might be looking and say, I would never expect my migration to empty my database or anything like that. So things you can build into your framework, which hopefully in CI would have actually, in CI with a reasonable data set, we might have caught that, or of course in production still, better to know sooner rather than later. So those are just little things. So if you're going to write that, this happens to be an example from the very project that Toby worked on. Just basically each script looks like, how do I go forward? I want to fetch a bunch of stuff, and for each one of those things, I want to make some update, and then I want to save it. Down looks like, find them all, reverse that migration. This is an example of a transformation that is reversible. versus destructive. If it were destructive, I would obviously then be looking to fetch the original. I would have saved the original content into a temporary collection, would have done what I needed to do, and here I would have been going and fishing that document back out of the temporary collection, for example, every second. And then the verify function, this is kind of my unit test, which says, hey, let's make sure that if I query for this thing I thought I transformed, it actually doesn't exist anymore because it should.
That's beautiful. You had that as a part of your CI process that did the migration?
Yes, every migration declared its own unit tests, and then there was the harness, which I don't have here, that ran also had these sanity checks. Toby could tell you if he thinks I was stupid. I kind of thought that was a good idea. But apparently it didn't save us from deleting the entire database, so as always.
It worked pretty well, but in this case, like, you're checking that there are none of those rows.
That's great.
What we did was delete all the rows in the up, so.
And again, like, tests don't matter unless the assertions are good, right? So we all know that. But so hopefully, again, it's just a different lens, like tests are, on the same database logic. So I don't know of any of the common tools. I actually think we should open source what we did because the ones that are out there actually are not even this good. They usually cover kind of this idea, but they don't kind of do more.
The Rails framework migrations has the versions table.
Yes.
To be able to do anything like that.
Yep. Same. And you're always good. That was what I meant by the timestamp. Sort of for the incrementals, you either have versions or timestamps or some mechanism to understand how far you've gotten, and so that you can pick up from where you've left off. And you can also recognize I'm looking at a database that looks nothing like I expect. I shouldn't go forward. Right. So again, if you use most existing tools I've seen, just kind of adopt that same model.
One idea that bounced around that I haven't really thought about too much is, since it's schemaless, would you add a version onto the document itself?
So not necessarily for this, but we do that a lot for other reasons, right? So if we're trying to
runtime migrations.
Yeah. So you could, if that was helpful in your migration. I haven't found that that's actually a necessity for this problem very often, but it could be. Yeah, it could be part of the solution. And with that, any questions before I drop off?
So we wanted to end on a bit of a meta point. We talked about a handful of the blips on the radar, hopefully in a semi-cohesive framework of web development. But there is this notion of the radar itself, and we have personally found value in building the radar. And we've talked to other individuals, other companies who have taken that model of building the radar and have also found it valuable. So we think there's some interesting comments just from talking about that on its own. So we have, Baji mentioned the 4 quadrants, tools, techniques, languages and frameworks, platforms. Those 4 quadrants are somewhat arbitrary. They're relevant for our business. We're a technology firm with a stake in consulting across all those 4 quadrants. It's not necessarily applicable to every case. So just to sort of walk through an example of how this might work in enterprise, one of the quadrants might be packages, vendor packages, which is pretty common in large enterprises. And I think the exercise of going through this is more relevant than the output. However, the point of it is that it provides you some principles for talking about the various options out there. So if I were to take this example of vendor packages, I would say, okay, well, what's important to me is I want testability, I want integratability. I want a very narrow suitability to task. What a lot of vendor packages do is try to solve the kitchen sink problem where you only want it to solve the drain problem, which leads to a lot of integration issues and a much higher total cost of ownership. And then you can also talk about IP. It's always useful in that example to have a geek read the contract just to make sure that any integration code you write isn't considered their IP. And then you can rank your vendors across maybe a similar set of axes around this hold, assess, trial, adopt, or maybe something that's quite different. But the key points is that it provides a principled discussion for future thinking around technology choices in your enterprise. And it's something that hopefully you revisit periodically, and it provides a nice communication medium for you to send out to your technology team. And it's actually quite adaptable. So we have an example within Thoughtworks. One of our Thoughtworks colleagues took what I thought was a very creative example of this. And this is his idea of a reading guide for technologists, for developers in particular. And he completely rethought everything about the radar. He said, okay, well, we have coding practice, architecture, thought leadership, methodology, and then the rings are advanced, medium, fundamental. So working effectively with legacy code, structure and interpretation of computer programs. So these, because everybody talks about them with their acronyms, WELP and SICP, you know that these are advanced. Whereas clean code and the productive programmer, nobody has acronyms for this. So you know that these are fairly fundamental books that you need to pay attention to. And that's kind of cool, because I think that's a really interesting way of sort of framing, in this example, a reading list in a way that makes sense depending on which area you want to focus on and how far down that path of discovery you are. So it is pretty adaptable. So Neil Ford has written an interesting article on how to do this. There are open source tools on GitHub that can help you create the visualizations for this. And the point is not to say, here's the quadrants, here's the rings, is to say that this is an interesting example. And one other aspect that I think none of us talked about is the shapes and the colors. So in this example, recommend, highly recommend. But in our example, triangles and circles, Baudry can probably tell you the exact definition, but I think it depends on whether they moved or not. There's a certain distance within.
Whether it's old or new.
Whether it's old or new. So maybe a triangle has moved, whereas a circle has not moved. Because a radar, if you take the analogy to its logical extreme, a logical radar, you can't detect something that's not moving, even if it's there. So it's the same notion that you really only see movement. So it's an interesting exercise. We have found value with it. We've talked to other customers who found value with it. So it's something that may be interesting for you to think about in your context.
The really cool part of it is, even if you can't, if you're working in an organization where you can't possibly, for organizational reasons, break down every single silo that exists and get people to work with each other on a daily basis, this at least provides an opportunity for people to come together and have a conversation as a technology organization where you're not working, but at least you can talk about it, and hopefully that leads to a better communication between the various departments.
And that concludes, I totally failed to add an ending slide, but if I had an ending slide, it would say Thoughtworks, thank you, Audrey. They probably have a nice logo on there, because we're sort of ambivalent about logos. Well,
You just have a little
yeah. So any questions?
about absolutely
Anything.
Yeah, including what you've seen on the radar that none of us know anything about.
This could be seated, this could be free-form conversation one way or the other.
Gauge matches or what you guys want to
Or gauge matches.
Is the reading radar available on the web anywhere?
This is he blocked it. So he's a Chinese guy. So everything except this
Is it Chinese?
ideograms.
Google, however, will sort of mess that up and help.
So it's kind of an interesting story. Like this actually like popped up as I think someone found it on the internet and was like, "Who is this guy that says Thoughtworks?" And I saw like this email thing going around, like, "Who is this guy?" And it turned out he's a Thought worker. It's a very good indication of Thoughtworks culture, I think, in many ways. Awesome innovation that no one was aware of. Yeah, it was a really interesting story. This guy, this Chinese Thought worker, had this awesome idea. I think it's actually just, aside from the awesome idea, it's actually a really good resource. There's loads of really good books on it. But yeah, it was, so everything else on the page, pretty much, is in Chinese.
Yeah.
So it's probably got some incredibly insightful things on that page.
We don't know what it is.
Is the actual technology radar data available as a data set somewhere?
We are working on making it available at this point. There are a couple of things in play. We're trying to make a slightly more interactive version of the radar rather than just a static PDF. What exact shape and form that might take and what exact features and interactivity might be available in it, we're not sure yet. But at least one of the things we're trying to address is that things drop off the radar after a period of time. Let me stand up, I'm short. Things drop off the radar after a period of time, so people can't necessarily go back and see what was there and what has dropped off. So that's one of the things that we're trying to address. And the other part we're trying to address is just make the raw data available, probably just as a JSON document of some sort, so that people can do whatever they want with it.
Butter says we're trying, it's not
excellent
because we don't know the technical
visualization when you just match some trends in, I don't know, number of job listings versus, I don't know, salary and match it against a place on the radar, you could come up with some.
And this is a great example of, like, that's the kind of thing that Thoughtworks love, is open sourcing and opening up that data. So we don't have to do the work, someone else is probably going to have some amazing
serendipitous, wonderful work gets created. And we're all big fans of that. So and the reason why we're doing it is because we're also going, if you've noticed, we're going through a huge big website refresh at this point, so there's just the matter of whether the website gets done first or whether that work gets done first. It's the same team doing the work, so we're trying to get that sort of stuff done humanly as possible without driving those people to death. Poor things.
So one of the books on that chart, I think, is the continuous delivery book.
Well done! Way to wrap it up!
Yeah, right? So if you haven't put either your business card or a piece of paper in here, you've got to do it right away, because we're going to pull a winner out of the jar.
Don't grab a jar.